This video is going to help you understand what I'm looking for in Project 2. So what you see in front of you is the project. At the top, I'd like you to type in your name for me and then indicate which of the three data sets you're working with, automobiles, homes, or apartments. Just kind of circle it or highlight it or get rid of the other ones, however you have to do it. Different classes have different due dates for Project 2, so make sure you get your specific due date correct and get it in on time. But what we're talking about are distributions now. We're talking about random variables and distributions, specifically binomials, normals, and sampling distributions, and this project has a little bit of all that. The first one is, I'll give you a hint, it's a binomial. Just for watching this, I'm going to spill my guts a little bit and tell you this is a binomial. I want to see if you can work with binomial problems. So unemployment is a big concern. It's estimated 30%. That sure sounds like a probability. We've sampled 25 households. That sounds like a sample size. And so that should help you identify the type of distribution. And now I want you to do it. We looked at the binomial tables. I want you to use the binomial tables. If you want to use some software, that's fine. I think the tables are as easy as it gets, and I'll be supplying them not only on exams, but I think in the description of the project, there's a binomial table for you there. I want you to find the probability more than 8 of the 25 have been directly affected by the coronavirus pandemic. In part C, find the probability at least 5, but less than 11. Might need to find a couple values in the table and work with it there. Show your work. Don't just put an answer here. If you just put an answer, I'll give you the point if it's right, but if it's a 3-point problem, then I'm going to take a couple points off. So show me your steps. Show me your thought process. Dots, you've seen me work with dots in class. Or just give little probability statements, but show me what you're doing. If you want full credit, you got to show me how you're thought through the process. So that's question one. And you'll notice, I should mention that question one, no printouts are necessary. So you don't have to create anything for me. You're just going to be using the binomial tables to solve questions B and C. In question two, I want you to give me your descriptive statistics. So go back to if you haven't generated it already, I'm going to encourage you to generate the printouts for project 2 watching my printout demonstration video. And you're going to give me a very short little printout here. It just has a sample size, which should be 75. It should have the standard deviation. It should have the mean. I'm going to assume, or you're going to assume, that the mean and the standard deviation are population values. I know they're for your sample. Just go with me here. But I want to say if you have a normal population with that value, the mean and the standard deviation, I want you to find the proportion of all sizes or mileages that fall between the 10th and the 50th observation. So you're going to type in the 10th, the 50th here, and then you're going to go through the work. Now, I have a lot of points attached to these problems. I want you to do just like you see me do in class, in the lectures. I want you to draw the X picture, put the 10th and the 50th observation on the X picture, put the mean in the middle. I don't know where your 10th is. They may be both, the 10th and the 50th may be both to the left, they may be both to the right. One may be below the mean, one may be above the mean, but draw the picture that you have and then create your z-scores. Show me the z-scores for the 10th and the 50th observation. The mean should be the value 0 in the z-score. And then go to your table and show me some probability. Label it. Draw it in with your hand. Take a picture of it. Try to label it any way you can. That's the point that everybody misses on this particular problem. I want to see the probabilities you get from the table somewhere in one of these pictures, and then solve the problem. Because the table probabilities you get won't answer the problem, but they'll help you answer the problem. So kind of make it look like the problems you see me do in class, and you should be fine. Part B, this is the point in the distribution. I want you to find the 6.3rd percentile. So again, draw me a picture. Okay, the 6.3 percentile, that's the point in the distribution where 6.3% fall in percentiles below. So draw me that picture and then go to the table, and there's a little formula that you're going to be using. Spell that out for me. Show me the work you're doing. So that's the normal work. And now C and D are sampling distributions. Suppose you take a future sample of 100 sizes and mileages. N is 100 here. I want you to tell me what the sampling distribution of X bar would look like. And when I describe sampling distributions, there's 3 things I describe. One involves a mean, one involves a standard deviation, one involves a shape. The mean and the standard deviation are related to the value of the mean and the standard deviation you found in your printout. I want you to use those again, but I want you to use a sample size of 100. And then I want you to use that future sampling distribution to find the probability that the sample mean would exceed your 50th observation. And again, same conversation I had with you a little while ago. Draw the X bar picture for me. I want to see your 50th observation. I want to see mu. And then I want to see the transition to the z-scores. Now, the z-scores you use here in part D there's a little bit of a difference between the z-scores you used in part A. And we've talked about the differences between x's and x bars, or at least we will have by the time you do this. And I want to make sure you're using the correct z-score. Spell out as much as you can. And again, don't forget to show me that probability. The probabilities get a little weird with sampling distributions sometimes because the z-scores get kind of large. Check out what we do when the z-score falls off the chart in our lecture time together. So draw the pictures, put in the probabilities, and that's the sampling distribution of x bar. And then there's one topic at the end of chapter 4 in the text where I talk about how do we know if we have a normal distribution or not? How do you assess normality? And I've talked about 4 different techniques for assessing the normality of a distribution. I want you to do this for the price variable. I want you to use 2 of those techniques, and you can use any 2 you want. The easiest 2 to do involve a stem and leaf display, and I've shown you how to generate that printout in my printouts demonstration, and something new, a normal probability plot, and I show you how to generate that. So I want you to generate 2 of the techniques, or the numbers that you need for 2 of the techniques, and I want you to go through it. You could use the IQR divided by S. You could use what we call the empirical analysis. That's a lot of work, but you could do that. Just kind of go through it, show me your work. In some cases, you just show me printouts, and then say, based on those printouts, I believe the prices, and the answer here, the assessment here, is you're going to conclude that you believe the prices are either pretty normal, or approximately normal, or you're going to conclude that the prices are not approximately normal. I don't care if they're skewed, I don't care if they're some crazy distribution, but just tell me the assessment here is either normal or not normal. And that's what I want. So hopefully that helps you understand. Ideally, you'll be doing the project as I go through the material in class. So the week of February 6th, which is when I'm filming this video right now, the week of February 6th, I'm going to be talking about binomials. You should be doing some binomial work, and then you'll head into the normal work. So if you want to keep up with me, at least do question 1 this week, and then next week do question 2 and kind of follow along. If you can work ahead, that's great, but at least as you staying current, that gives you your best chance of success. And as always, when you have questions, you can always reach out. The TAs and I are ready to answer your questions, whether it's for my live classes. We have some live office hours. And then there's also online office hours, and of course the online class. That's the only way we have office hours with you guys. But join us. A lot of times I sit during my office hours and I'm doing something else because nobody's asking me questions, and I'd rather be talking to you. So hopefully that gives you a feel for what's wanted. Do your best. Obviously you're working by yourself here, and this is preparing you for that next exam. So do the work, put the time in, and I think it'll help you learn. So good luck, and talk to you soon. Bye.